two samples of same material have the same mass but different surface areas. Same mass means like they have the same number of particles as well, okay? Because the mass is a characteristic of the particle. So if I say 100 particles in X, there are 100 particles in Y as well. Now the question is, each sample first initially it was heated to same temperature. Like let's say this is at 50, this is also at 50. Okay. And they are left to cool to a room temperature. So room temperature is 25, so they will reach both 25 as they cool down to so the sample is allowed to cool to the same final temperature. Like as they cool down, they reach the room temperature. So the change in temperature for both is same, like X will be same as Y. Which row correctly compare the decrease in internal energy? Internal energy depends on the state as well as it depends on the temperature. Here state is not changing. The substance remain in solid, but it is only changing at temperature, and the internal energy depends on number of particles as well. So when we talk about internal energy depends on the particles, and it also depends on the temperature change, and it also depends on the change in state, like solid turning into liquid, liquid to gas. So number of the particles is same for both. Change in temperature is also same for both, and there is no change in state. So what about the internal energy? The decrease in internal energy for X and Y, as they have the same number of the particles, they have the same change in temperature. So the same way they will have, like X and Y lose the same quantity of energy. So either C can be an answer or D can be an answer. But what about the initial rate of cooling, like in the beginning, which will cool down faster? As I mentioned, Y is having a large surface area. Large surface area, so means it will lose energy from more sides, or like more particles are exposed to the surrounding. So in 1 second, it will lose more energy as compared to X. So rate of cooling or initial rate of a cooling for Y will be more than or faster than X. So large surface area cool down faster as compared to small surface area. But the internal energy, which depends on number of particles, depend on the temperature change, depends on the change in state, that because they have the same particles as they have the same mass, material is also same. That's why we conclude they have the same mass. And the temperature change is also same. They reach the same room temperature from the starting initial temperature, and there's no change in state. That's why they have the same decrease in internal energy. Is it clear?